Okay, chapter 4, we have, so for some of you, complete new material. Okay, I'll be showing you how to plug things in a calculator, so you need to be paying attention and watching this. Obviously, you can rewind it if you need to, or pause it. I'm going to be plugging stuff in faster. If you can't keep up, just pause the video, plug it in yourself to see. Okay, so this is about matrices. Some of you may or may not have seen matrices before. Okay, they've taken them out of a lot of the Algebra 2 books, but they used to always be in them. You can see on a placement test, so it's important that you know this. It's not hard. A lot of it can be done on the calculator. I'm going to show you how to do it on the calculator since we're out of time. If I was in class, I'd show you how to also do it by hand, but we don't have time for that, so I'm going to be showing you how to do it in the calculator. So at least you, if you come across this on a placement test, you can plug in a calculator if nothing else. Okay, so matrix, you have rows and dimensions. Rows go this way. Rows and columns, I meant rows and columns go this way. You have to know that. Rows, columns. Okay, so it's saying in this problem to put it into a matrix. So we'd have 1, 2, 3, 4, 5, 6 rows and 2 columns, such as what we have down here. This is a 3 by 3 matrix. Okay, yours just would be 6 rows and 2 columns. Okay, and just filling those numbers in. That's all there is to that as far as putting it into matrix format. Okay, now, as it says here, identify A. So these are called elements. Each number in your matrix is called an element. A is just the name of the matrix, and then they want row 4, column 2. That's what, it's not 42. It represents the element in row 4, column 2. So I go up here, row 4, 1, 2, 3, 4, column 2. Obviously, this is column 1, this is column 2. So the answer would be 30 right there, row 4, column 2. Okay, so you might even just see that on the placement test. What name the element, you know, A42. Okay, so just even understanding that could be free points. All right, adding, subtracting matrices. In order to add, subtract matrices, the dimensions must be the same size. The dimensions must be the same size. If they aren't, you cannot add them. So dimensions would be how many rows by how many columns. So notice these are 2 by 2, 2 by 2. And that's how you identify it with a time sign in between, and you pronounce it by 2 by 2, 2 by 2. So these are exact same dimensions, so I can add or subtract them. So all it does is, for example, tell me 9 minus 7. I subtract or add the exact same spot in that original matrix to the second matrix. So 9 minus 7 is 2. Goes in that spot. 2 minus negative 5. 2 minus negative 5 is positive 7. 8 minus 6 is 2. And negative 1 minus 3 is negative 4. And there's your answer right there. Okay, that's for adding and subtracting. Now, they could have a coefficient out front, such as number 5 here. It just means multiply negative 3 through each one. And so that becomes negative 9, negative 30, negative 63, and positive 12. Very simple. Okay, now, so we can add these ones. You can do number 3, because again, it's a 3 by 3 and a 3 by 3. So I can add them. If they were different dimensions, I could not add or subtract. Now, you can on multiplication. The rule of multiplication is the 2 inner numbers. So these are called my inner numbers. Those 2 right there, the ones closest together, versus the other 2s would be my outer. Those would be my outer numbers. That's the outer numbers tell me the final matrix size. Okay, the final matrix dimensions. The inner, these have to be the same in order for me to multiply at all. There is no division of matrices, multiplication, addition, and subtraction. So what's the dimensions here? 3 by 2. And what's the one here? 2 by 2. So notice my inner numbers are the same, so that means I can multiply those, and my final matrix size will be a 3 by 2. So 1, 2, 3, and 2 columns. So I could already go ahead and put those in there, because that's my final matrix size at 3 by 2. Okay, before I do my calculation, so I make sure I put them in the right spots. And then what you're doing is, on the first matrix, you circle your rows. The second matrix, you circle your columns. Okay, so I'm actually showing you how to do it by hand real quick, but I'll also show you how to put in the calculator. So what I do, and that's for all of them. the rows in the first one, columns in the second one. So this is row 1, and that's column 1. So that's going to go in row 1, column 1's answer right there, row 1, column 1. I go 2 times 2 is 4 plus 1 times 1. So 4 plus 1 is 5. For the next one down, row 2, column 1, I go 3 times 2 is 6 plus 0 is 6. So I'm multiplying the first two together, multiplying the second two together, and adding them in between. And I have 7 times 2 is 14. I can't see what these numbers are, so I got to erase right here. So on this one, I'd have 7 times 2 is 14 plus 4 is 18. Then I go to column 2. Okay, so it's going to be for another one. Do the exact same thing. 8 plus 6 is 14. Row 2, column 2. 12 plus 0 is 12. Row 3, column 3. 28 plus 24 is 52. Okay, now let's see that we get that on our calculator. Okay, so on the calculator, let me bring it down here so you can see it. Okay, I go to matrix. Second, right there is matrix. Name is fine. First matrix will be A. I go over to edit and hit enter. It asks for the dimensions. What was the dimensions of this first matrix? So 3 by 2. 3, enter, 2, enter. Now it asks me to fill in the numbers. 2, I hit enter after each one. 1, 3, 0, 7, 4. Okay, so that's matrix 1 done. I go back, hit second matrix again. This time I'm moving down to matrix B. Okay, hit right arrow, go across. I guess I got to go to edit first. Go to edit, then down to B. Okay, edit first, then down to B. Hit enter. Again, it asks for the dimensions. That's a 2 by 2. So 2 by 2. Okay, fill them in. 2, 4, 1, and 6. We have them right there. Second, quit. Go back to the main screen. Okay, main screen. Now what did I do? I'm multiplying those, aren't I? So I can just do second matrix, and it's A is the name. I use the name, so I just hit enter. I put A there. I don't even have to hit a time sign. I can just put B next to it. So go down to B. It's going to put B matrix there. That it knows to multiply it, and there's my answer. The exact same thing that I have written down on the paper right here. Okay, so I showed you how to do it by hand. It doesn't matter the dimensions. It's always rows. It's always rows that I'm circling in the first matrix. Columns I'm circling in the second matrix. Okay, and that's a spot. So you can choose to work it out by hand and possibly check in the calculator, or if you want to do it all in the calculator and just put down the answer, I'm fine with that as well, as long as you can do it one way or the other. That's how you do these. Okay, I could have done that with the addition ones, but addition or subtraction, you should be able to quickly add or subtract those in your head, but you could have put those in there, and this would be matrix A, and it'd be a 3 by 3. That'd be matrix B and a 3 by 3. And back on the main screen, you put A, and then this time you would put a plus sign, and then bring up the name B, and it would add those together. Okay, so that's how matrices work as far as add, subtract, and multiply. Okay, let's see. 8, right? The vertices in matrix form. Okay, so we're going to have 3 rows, 2 columns, so it's going to be a 3 by 2. Okay. Rotation of 180, just so you know, that is negative x comma negative y. Whatever the original coordinates are, the original xy coordinates now become negative x, negative y's rotation of 180 from geometry class. Dilation means just to multiply each of your coordinates by 1/2, because that's a scale factor. Dilation 1/2 is a dilation of 2. I'd multiply all my x and y coordinates by 2. Okay, if I reflect over the line y equals x, my original xy coordinate now switches and becomes y comma x. So switch your y's and your x's. Find the determinant. Okay, the determinant, we're just going to have to put that in a calculator. So again, this is a 2 by 2. We're going to put this in the calculator and have the calculator do that, because again, I don't have time to go over all this by hand here. So matrix, okay. Go over to edit, enter. This is a 2 by 2 this time. Enter it in, -6, you must use the negative sign. -7, got to use a negative sign. 5 and 8. Okay, go back to second matrix. Oops, not, I did hit math. Matrix, I want to do something math-wise. I want to find the determinant, number one. So hit it. Oops. Sorry, I got to. Let's delete this out right here. I forgot to go to the main screen first. Delete that. 2 is 8. Hit enter, so it's there. Okay. Second, quick. Go to the main screen. Now do second in matrix there. Go over to math. We want to do the determinant, and we want the determinant of what matrix. We put our answers in matrix A. So just bring up matrix A. Second, oh dang it, second. And matrix A is right there, the name, puts it right there, and just hit enter. And there's the determinant, negative 13. Okay, determinant, it's real quick with a 2 by 2. What you're doing is you're taking these two, multiplying them together. So that's negative 48. And then subtracting the multiplication of these two. 5 times negative 7 is negative 35. Negative times negative is positive. I got negative 48 plus 35 is negative 13. Okay, that's doing it by hand. That'd be showing you work that way. So 2 by 2s are easy. 3 by 3s, what you end up having to do is you'd have to extend, repeat these first two columns out again, because you have to take all the diagonals, that one, multiply all those together, each diagonal, and then add all three diagonals together, and then do the same thing, but subtract these three diagonals together, okay? So again, we don't have time to practice that. Just put in the calculator like we just did on number one, do the determinant, and have it kick out its answer for you. But that's how you would do it by hand. You could always look it up on YouTube if you really want to know how to do it by hand, like I just showed you right there. Let's see an example on that. Find the inverse. Again, doing it by hand takes a little more work, so I'm just going to show you how to put in the calculator. Again, it doesn't matter. You just make sure you name the dimensions. So that's a 2 by 2. Okay, so let's hit that one. Clear that one. Second matrix, edit. Dimensions are 2 by 2 already, so let's go ahead and fill in the numbers. 6, 2, 3, 2. Second quit. Okay, and we will find the inverse is what we're looking for right there. That is like a to the negative 1. That's inverse. Okay, so I hit second matrix, go over to math. I want to do something. Does it not do the inverse for me? Oh, I thought it did. Okay, I might just have to skip that one then. We don't have time to go through it by hand. I thought, see, an equation. I know. That's what I do. Okay, go back here. Second matrix. Dang, matrix. A. And then I hit to the negative 1. Or I told you that's what it means right there. Hit to the negative 1 on the screen. I already had it written up here. I was looking for that underneath the math. I forgot they didn't have it there. You actually just type it on the screen. I haven't done these in years. Okay, so I forgot. All right, so I said enter. And it gives me my answer. Notice that's 0.3 repeating bar, which then you should know is 1/3 is a fraction. Negative 0.5 right here. And then in order to see what the other two numbers are, I have to right arrow. Negative 0.3 repeating bar, so it's negative 1/3 and 1. And there's my inverse. Okay, and I just do the same thing for 12 or 13, 14, 15. So I'd say A inverse is that. What that means is if I multiplied these two matrices together, I would get this matrix right here called the identity matrix, because it's 1. It multiplies back to itself. It's like multiplying something like 5 times 1 is 5. This is the identity matrix, just so you know, in case they ask you that on a placement test. You have 1s down your column, down your diagonals, and every other spot would be 0s. So if it's a 3 by 3, I'd have 1, 1, 1 there, and the rest are 0s. Okay, it's 1s along the diagonal right here. Everything else is 0s, and that's called the identity matrix. depending on whatever dimensions. That's a 2 by 2, that's a 3 by 3. You can do it 4 by 4, etc. Okay, so what happens is when I find the inverse, I multiply these two together. Okay, I would get the identity matrix. So that's what they're looking for. You're not going to do it by hand. Like I said, we don't have time for that. You just plug in a calculator and have it kick it out for you. Okay, solve each matrix. All right, so this is like saying like 5x equals a number, like 10. What do? I divide by 5. Well, instead of division, we can't divide with matrices. That's why we do the inverse. That's why we just found those inverses. So I'm going to have like 5 inverse, and whatever I do on one side, I have to do on the other side. Okay, so 5 inverse. So in this case, you're thinking A. The general equation here would be matrix A times X equals matrix B. To solve for X, I have to do multiply A inverse on both sides. It's got to be on the left side over here, not on the right side. It may not be able to multiply at all doing that. So in matrices, the side that you put the matrix on matters. Okay, so A inverse is always on the left, so it's got to be on the left over here as well. Just know that. So this is how we solve. This is what you type in the home screen. On the main screen itself, that's what you're going to type in. So all I have to do is type in that piece, the right side. Okay, so obviously I have to fill this in with matrix A, this with B is all I'm doing. I'm just telling you right now that I'm going to pop through it quick. And then I go back to the home screen and type this in, A inverse B, and it'll give me the answer for X. It's like solving for X and Y. There's two variables here. Okay, so you're going to have two answers. Okay, so let's go ahead and do that. All right, so I can clear this out here. All right, so second matrix, go over to edit. Edit. Matrix A, we're doing a 2 by 2, so that's still can stay the same. Fill it in, 3, 4, -1, -1. Okay, and now I go second matrix, edit, go down to B. B's matrix, what's that dimension? That's a 2 by 1. So the 2 is fine, hit enter, but I gotta change this one to a 1. Oops, put it in here. What are my numbers? 3 and 2. 3 and 2. Again, if I'm going too fast, you can obviously pause the video, practice it yourself, okay, to plug in yourself. All right, so now I have A and B in there. So I just go back to the main screen, like I just told you, go back to the main screen and type in A inverse B. So second quit. Now go ahead and type in the A, oops, A, enter, inverse, and second matrix, down to B, enter, and now just enter again. So that means the X coordinate is -11, the Y coordinate is 9. X equals, what did I just say it was? -11, and Y equals 9. That's my point of intersection. I don't know why it's coming out like that. Let's go ahead. X equals -11, Y equals 9 for that answer. So what this really is, just, these are two lines, and you're finding this is a way of solving systems of equations. You can put it on matrices. Your Algebra 1 and Algebra 2 teachers didn't show you this. In Algebra 2, we used to show you this all the time afterwards, because otherwise kids could just cheat and just pop in this in matrix form and have it kick out the answer all the time. They didn't even have to solve for Y like you had to do on the graphing calculators now. So what this equation really says is 3x plus 4y equals 3, and -x minus y equals 2. That's where those two equations are that we put it in matrix form. The left side is matrix A. It's just the coefficients is what it is. That's why you see 3, 4, -1, -1. And the right side, the constants, is matrix B. Okay, so now you know how you can solve system equation was 2 by 2, 3 by 3 with matrices. So you could do that right here, like we're talking about with number 3. Okay, I just plug in my A is the coefficients here, and B is the constants here, and then go back to the home screen and type in your A inverse B, and it'll kick out X, Y, and Z. It's not going to say X, Y, Z, so you just give you the three numbers. But the first answer is X, second answer is Y, third answer is Z. Okay, and you're going to practice it on 22 here as well. Okay, so now you've learned a different way of solving systems of equations. All right, this one, don't forget, this is saying multiply everything by 3 inside of here first. Okay, and then my equation would be 4x, let's just do the first one here, plus 9, I do 3 times 3, equals this 10 right here. Okay, so I would subtract 9 across, so I have 4x equals 1, x equals 1/4. Okay, for that matrix. I'm trying to find the entire matrix. Okay, 4 times some matrix plus 3 times some matrix is going to equal this one right here. So that's for that spot. Now I have to go and do for the next spot 4x. Was that plus or minus? I can't see. 4x plus. So for this one to this one to this one, it would be 4x plus 6 equals 8. Subtract 6 across 2, x equals 1/2. So that'd be the 1/2 spot right there. Whereas the first one was 1/4. Okay, and I'd go, that's 3, 4x plus 3 equals 5. Solve for it, that spot goes there. Okay, and you go ahead and do that right there. Okay. All right, so solving systems, don't worry about using Kramer's rule. I don't have time to teach you that. That's another way of solving systems by hand. That's longer. Just go ahead and use matrices. Okay, on this problem again, just like we just did up top. Okay, just practice again with matrices. Here it says solve using augmented matrix. That's all by hand. We're not going to do that. Use matrices again. Just plug in your calculator, have it kick it out. Just one more practice. That's all I care to have you understand here. We don't have time to go through it by hand. Okay, they don't even have them do it by hand anymore. I had to do it by hand with way larger ones than this, and it would take 2 pages to do one problem. Okay, when you have like a 6x6 matrix. Okay, that's what I do in college math, linear algebra. Now they don't even have to just have a graphing calculator kick it all out for you, so these kids don't have to know nearly as much. All right, 26. Write 2 by 2 matrices A and B. Show the multiplication of matrices is not commutative. Where commutative means I can switch the order. Remember I told you how the order of matrices mattered? So, for example, if I took 2 by 1, 2, 3, 4, and multiply by 4, 5, 6, 7. Okay, you can do this on your calculator. Multiply those together, you get this answer. And now what it's saying is now switch it. Put this one first, 4, 5, 6, 7, and 1, 3, 2, 4. Now multiply those two together, and you will see that these are not equal. So matrices is not commutative. You need to write down an example yourself. You can use those exact same numbers right here, pop in your calculator, and go ahead and show that so it's on your page for your work. I don't care, you make up your new numbers, but you're just showing that A times B does not equal B times A in matrices is what you're showing here. Are these inverses of each other? Remember what I said, if they're inverses, so all you're gonna do is you're gonna multiply this times this, okay? If it's an inverse, remember it's gonna come out as 1, 0, 0, 1, as I told you before. If it doesn't, you need to explain. Obviously, write down what it actually does multiply to, and you say it's not an inverse because it does not equal that. That's what an inverse. If there are 2 inverses of one another, always multiply. As I told you, 1's down the diagonal, 0's everywhere else. What are the dimensions of the product of a 2 by 3 and a 3 by 4? So here it's just testing you, and you might have this on a placement test. It says, what are the dimensions of the product? That means the answer. Remember, I told you in order to multiply the 2 inner numbers, 2 by 3 and a 3 by 4, I told you the 2 inner numbers must be the same, which they are, and the 2 outer numbers are the dimensions of the product. So your answer here then is a 2 by 4 matrix. Okay, it's the outer numbers. Don't forget that. All right. This is taking a system of equations. Right, that's a system of equations from Algebra 1 or Algebra 2, either one, and then solve it. So they want you to solve it using matrices. Okay, as I told you before. All right, that goes ahead and ends this one, 25 minutes.